Hi and welcome to the video for the introduction of Camunda Cloud. My name is Thomas and I will guide you through today's session. So we'll start off with showing and comparing the Camunda Cloud product against the Camunda Platform product. And afterwards we'll also see how to actually configure a light automation using Camunda Cloud. So without telling you any more in advance, let's start right away and dive deep into the Camunda Cloud topic. Let's go. When taking a look onto Camunda's product page, we can see that there are two solutions available, Camunda Platform and Camunda Cloud. So there is this kind of enterprise platform and workflow and decision automation software, which you are most likely familiar with. If you aren't, check out my previous videos, and there's this Camunda Cloud process automation as a service option which can be chosen. So what is the difference between those two provided services? Let's take a look on a comparison. After having opened up both product pages, we can dive into a more detailed comparison. So on the left side we do have Camunda Cloud. On the right side, there's our Camunda Platform offering. Taking a look on the various products, for instance, in the design phase, we do see that they actually do not differ at all. So for Cloud or for Platform, you can use the Modeler and Kavime. The same, of course, applies to the improvement phase. So there you do have Optimize for both of those offerings. So where's the difference now? And of course, I want to really highlight that there's this new workflow engine, which is called Zibi. You might have heard of it if you are familiar with Camunda as of now. And this new workflow engine is so different from the previous one that there are many technologies which have changed until of now. So for instance, you do not need a relational database anymore, and everything is managed in Kubernetes. Besides of our Zibi, we also have a so-called cloud console, which is used in order to simply manage your Zibi clusters. And of course, there's some kind of operate tool, which is quite similar to our Camunda cockpit, but just applies for this Zibi engine, because we cannot simply reuse the old cockpit version. Both of our tools also provide task lists, but they do differ as well. For instance, the new task list also is compatible with those Camunda forms which recently came up, and hardly rely on those. So these are the fundamental changes in terms of product stack. Now we are going to discover them by ourselves. So we will create a new cluster with Zibi and launch operate, go into the task list and see how we can create our own little automation. When you are interested in following what I'm doing with a step-by-step guide, feel free to head to docs.camunda.io and just check out here this Get Started guide, which will easily guide you through all the different possibilities you do have in order to get familiar with Camunda Cloud and Zibi and to try it out by yourself with a 30-day trial. When opening Camunda's Cloud landing page, you can see that you can easily sign up for a 30-day free trial right here. So just enter your credentials and all the information which is necessary in here, and you can start right away. Besides, of course, we can easily log in here as well. I do have an account already in place. So we get right away to our Cloud Console. And this Cloud Console simply displays all necessary information which we are going to need in the context of Camunda Cloud. So for instance, taking a look on our diagrams, we can create a new one right here or upload them to our Cloud Modeler. We can create forms which are then used in our task list right in this tab, and last but not least, we can create clusters for our workflow engine right in here as well. And that's where we are going to start with. So in order to automate a process to run something on Camunda Cloud, we do need a cluster which contains such kind of ZB engine. We need to have this kind of operate, so on and so forth. And in order to do so, we just click here, we create a new one, and we call this now dev cluster. Having done so, we go for the stable release ZB 1.2.1 in the region Europe West. That's perfectly fine. We can create it, and now we just need to wait a while until it has been created and is booted up successfully. Now our cluster has been created and we can have a look into the details of it. So right here you can already see, hey, there's our dev cluster, there is no client configured yet, so this is maybe a thing we need to do in the future in order to attach some workers to our Camunda Cloud instance, to our ZB instance, and besides of it, we can see all those different tools down below. So ZB is running, so the workflow engine is running and is healthy, operate, task list and optimize are healthy as well. And now we can launch those tools. So for instance, stepping into operate, we can see this new cockpit version, more or less. And there you do see how many running instances we currently have. We can step into those instances, and then we discover pretty soon that currently nothing is running in our cloud cluster. So no action is going on or whatever inside of our ZB process engine. So at this point in time, there's not much to see. Let's go back to our cloud console, because we still do have the task list and optimize. And of course, task list simply displays all the available tasks which can be picked up by clocks, for instance, to be worked on. And optimize is the tool in order to run our process analysis. So we do launch right here, and when we would have some kind of process automated in Camunda Cloud already, we can simply analyze the efficiency and effectiveness of our process right in here. So these are the three tools provided within this Camunda Cloud cluster. And now we need to create a process, a simple little one, in order to show how these tools actually work and how we connect our business logic towards this kind of process engine. Great. So without further ado, let's continue and take a look into the diagrams and the modeling possibilities. In order to model a diagram, we can either use this web UI, this web modeler, or we can rely on the Camunda modeler for the desktop application, which is down here in the left corner. So you can download it, model your process, and then deploy it via code to Camunda Cloud. For the sake of simplicity, we are going to use the cloud modeler, so we can create a new diagram right away. And the process I want to automate in this short video is all about finding the right recipe to cook and then displaying it to a user. And of course I want to have the choice of the recipe automated, because personally I can never decide what kind of meal to cook, and due to this it usually ends in pizza, which isn't that healthy. So I want to be more healthy, and therefore I want to have some kind of automation which helps me to decide on what meal to cook. So therefore, of course, we do need a service task in the beginning, and this is called, for instance, choose recipe from cooking website. So I guess there should be some kind of cooking website out there which provides a very nice API which can be used in order to simply gather some kind of random recipe. And of course, this can be handled automatically. After having done so, I want to make a decision whether I actually want to cook this meal or I want to have a new decision and a new recipe which I can then decide on. So therefore, let's go with the user task right here. Oops, I didn't want to delete it. Let's go with the user task right here and say decide on recipe. And in case we want to cook the meal, we continue right here and can say, yeah, we do want to cook it. So please display and display and cook recipe. Oh, cook meal. Let's put it this way. And afterwards, we have ended the process successfully. Of course, in case we decide not to cook the meal, we can jump right to the beginning of the process and yeah, choose another recipe automatically. So let's put it this way, and of course we need to name the start and the end event properly. So let's call it hunger occurred right here, meal cooked, hunger satisfied. Great. Then we do have a little process pool. I do like them by a lot, and afterwards we are basically finished. Find and cook meal. Great. So that's the process we are talking about in today's session, and now as a next step we would then enrich those technical attributes in all these little tasks in order to actually automate it. Great. So let's start and reduce our 4 errors which are displayed. As a first thing, we are going to take a look on this service task. So let's make it a bit bigger and see what this little error is showing. So the property type is missing, and that's a very easy thing to add, because as you can see, this is a service task. So we want to have a worker to pick this task up and to work on it, and therefore we need to define a type. If you are familiar with Camunda platform, this is equivalent to the so-called topic. So now we can choose some kind of type, and I will call it recipe minus worker. So great. This has been defined properly right now. And yeah, continuing, we do have this kind of user task. That's perfect. We do not want to set something right now in here. And we do have this cook meal exclusive gateway. In order to do a decision, we do need to configure some kind of expression. That's pretty important. And in order to decide whether we want to cook the meal, we need to access a variable which was set in this user tasks. So maybe we do need to define an output parameter right in here. So let's set the process variable decision to true. Of course, we can set this differently in the user form itself later on. Afterwards, we can then step into here and define a conditional or an expression. And there, as you might know from Camunda platform, we simply define such a thing and say decision equals true. And since this is evaluated as true, we continue down this path. Okay, so right here we do need to do the same. So let's put in our expression, and we want the decision to be evaluated as false. After having done so, we should be routed down this path. And of course, in order to display and cook the meal, we need to simply select the user task. It seems that I forgot about it. So perfectly. Now we do have some kind of executable process model. We can also try out this token simulation so you can see how this behaves. It is even better when you do have more complex process diagrams, and as you do see here, once we've started the process instance, we can see how this token flow through the system. And in case we do want to go down the other path, we can try doing so. Now this should be interesting because it will be an endless loop right here. So we cannot, we can change it even during its runtime. Perfect. And now the process is finished. So great. Now we have designed a proper process model. In the next step, we'll take a look on how to create forms in order to display information in our user tasks right here. In order to create forms for our user task, we need to step to the Forms tab right here. And there we can easily create a new one. And as you can see, it's fairly simple. So basically what we need to do, or what we can do, is to add multiple kind of elements into a form. And after having done so, we can simply save it and apply it to a certain user task. So maybe even though it's dump, let's save this one right here. Maybe we should rename it and call it dump form example. Let's do so. When I switch to our newly created BPMN diagram, you can see that I can now easily add this form to our user task. And then you can see all the JSON configuration which is loaded into here. And that's basically how those forms can work and how you can attach them to a certain task within your process diagram. Great. So now let's create a meaningful form. First of all, we need to create a form for our user task decide on receipt. So therefore, let's simply create a new one. And first of all, before we do forget, let's give it a name. So let's say decide on receipt form. Perfect. So having renamed it, we can now add some kind of elements to our form. And I decided to go for a text field in order to display the title of our recipe which we are going to cook. So therefore we are going to change this key right here, because this key maps to a process variable. So what I'm going to do is I'm going to add the variable recipe title, and afterwards we are going to map a process variable to this text field, so it's displayed right in there. Having done so, we do require some additional checkbox in order to accept or decline this kind of recipe. So therefore we simply set this checkbox to decision, because we have used this variable later on in the process in the exclusive gateway as well. In order to have it a bit more nicely, we can now also add some further labels. So let's call this recipe title, and we are going to have the checkbox called do you want to cook this. Great. After having done so, we are finished with our first form, which can actually be used in our process model. So let's save this one right here. And now we can create another form, which is now used in order to display the recipe and cook the meal. Great. So creating a new one, it's the same procedure. So let's speed it up right here a bit. Now we actually do need a text field, and this text field is going to display the recipe or the content of the recipe. And of course, recipe, we do change the label right here as well. Additionally, we are going to add a button in order to submit it as soon as we are finished. And after having done so, of course, our process ends successfully. So let's save it as well. And now the only thing which we are going to do is to add these kind of forms to our diagram. So let's switch here. We do have our process right there. And now we can easily attach these forms to our process. Great. After having done so, we are now finished with that. So what else are we going to need in order to actually run this process? And that's fairly simple to answer, because we have added now our forms, we have implemented or designed the process properly, and now the only thing which is left over is to implement some kind of service task right here in order to choose the recipe from a cooking website and to provide the information to the workflow engine. So how is this actually achieved with Camunda Cloud? As you have seen, the only way we can specify some kind of implementation or some kind of type in here is via this little field here, and there we have added the recipe worker. And Camunda Cloud makes use of the very well-known way how Camunda works with external task workers, so it's fairly similar. So let's take a look onto this website, because this picture describes it very well. So we do have our ZB workflow engine on the right side, and we do have our service task, for instance, retrieve money or fetch a recipe from some kind of cooking website. And this task is published to some kind of queue. And we do write some kind of application in whatever language you prefer. We are later on going to choose Spring Boot, or we could do this also in .NET, Python, you name it. And this client application is now simply pulling from the workflow engine's API from this queue and fetches one or multiple tasks, which are then handled by our little job handler down here. And of course, once they are completed, we do provide all the results back to our workflow engine. And that's what we are going to do as a next step in Java together with Spring Boot. Taking a look on this documentation, we can see how the Java client actually needs to be implemented. So we do have the possibility to do it right away via Java using this dependency, but we could also use the Spring integration right away, which is elaborated on down below. Right here we can use the so-called Spring ZB dependency. Let's take a look on what this is. And right here we are redirected to a GitHub repository for this Spring ZB dependency we are going to need. And as you can see, the only thing which is necessary to do is to add this to our Spring Boot starter. And afterwards we can simply follow this guide and implementing such kind of job workers. Of course, we do need to configure somehow a connection to Camunda Cloud, and therefore we need to create a client which was elaborated on right here. So when we click onto our cluster, we can see no client is configured, and in order to retrieve all these dependencies and properties right here, we need to create this. But this will be done later on after we have implemented everything in Java or Spring Boot right away. Great. So let's start with the implementation part now. In order to get started, let's initialize a new Spring Boot project. So generally I've created a project within the group com.camunda cloud, and I will going to name it recipe worker. I decided to choose these kind of very standard settings from the Spring initializer here, and we can generate a project right after. So in the background I have already opened up my IntelliJ IDE, where I opened our recipe worker. So this is the standard configuration we have seen before. As you can see, our recipe worker for cloud should be created in here. Cool. So first things first, we do need a dependency in order to simply connect to Camunda Cloud. And as shown previously, we do have the so-called Spring ZB dependency, which can be used for such purposes. And this allows us to simply, as it shows up here, leverage ZB with your Spring or Spring Boot environment easily. So it's a wrapper for the or around the ZB Java client. And in order to make use of it, we can simply copy this dependency into our POM file in IntelliJ. So let's do so, adding it in here. And we already do have proper version here, so just fetch the new dependencies, and then we should be ready to actually implement one of the workers. Okay, after having done so, we can take a look in our application which starts up our Spring Boot project. So as you can see, there's our main method, and for this class we simply need to add another annotation in order to enable the ZB client. Besides, we can also simply start adding the implementation for the ZB client, and therefore we can simply write client p worker. So this is the annotation we are going to use. Type recipe worker. Let's clean this up, and now we do have a method in order to handle this kind of work. So public void handle job job client final active job. And you can find all this kind of information in the documentation of the repository. And somehow I activated job. Okay, here we go. That's correct. What's missing up here? To create annotation. Oh, ZB client. I did something wrong in here as well. So this needs to be a ZB worker. Perfect. So now everything is more or less set up from the structure of the class. Besides, we can now just have this method as a stub for our business logic, and some point in the future we want to complete the command, or we want to finish the job, and therefore we need to pass the job get key, and we can add some variables in here as well. Oops. variables chup, and these are contained in some kind of JSON object. Perfect. So after having done so, we do send this exceptionally available, and in case something goes wrong, we throw a new runtime exception. Could not complete job, and add the job and the I messed something up in here. Perfect. So that's what we need in order to get started with our business logic. And as you might think, this example should show how we actually fetch a recipe from some kind of website. So taking a look back into our process diagram, we can see our task in here is to choose a recipe from a cooking website. And I decided to go with a cooking website called Spoonacular, which does provide an API. And this API is fairly easy. So taking a look into the documentations, we can see that somewhere in here, let's search for it, we can get a random recipe. And that's what I apparently want to do. And we just can do so by sending out this kind of GET request. So that's perfectly fine. Let's try it out in Postman before we actually implement some kind of HTTP client in our Java application. Having opened up Postman, you can see I copy and pasted our Spoonacular link right up here. So I get a one random recipe, and I've added an API key which I created for this purpose. So everything is set in here. I can send out this GET request, and afterwards I will receive some kind of recipe. So let's take a look on this little JSON file, which is rather big. It has about 400 lines. So that's nothing small to work with. And you can see we do have a lot of information in here. So we can see this recipe isn't vegetarian and isn't vegan. We can take a look on the ingredients right here: spices and seasoning, cinnamon, so on and so forth. And when we go down, after we have gone through all the ingredients, we can take a look on the title, and it's called Slow Cooker Pork and Garbanzo Beans. So we certainly need this title in order to display this to the user. Switching back to our process diagram right here, you can see that we need to decide on the recipe in this task, and therefore we need to display a title to the user. And later on, we also need to display the instructions so that our user can cook our meal. So therefore we definitively need to simply get a few attributes from this JSON response. And one is the title. Another one which might be interesting is ready in minutes. And of course the instructions down here. So we do have 3 to 4 properties we can use. I do not want to parse this whole document because it's rather big. So we just want to write an HTTP client, getting such a response, and then copying a few or parsing a few attributes into a recipe class. And that's what we are going to do now in IntelliJ. Let's start. So I speeded up the video a bit and created our HTTP client and a recipe class, a recipe pojo offline. But we'll go through this right now as well. So what I've done here is I have created the class HTTP client. We do have a constructor in here where we can set the URL and our API key, which was provided by Spoonacular. And afterwards we can now easily make an HTTP GET call. We afterwards get a response, and we cast this response to string. Later on, as you can see up here, after we have received our string response, we continue to pass our response to a recipe. And that's what's happening down here in our class pass response to recipe, or in our method pass response to recipe. And there we simply use the Google Android library, I guess it is, in order to fetch certain attributes from our JSON object in order to set these in our recipe POJO. And afterwards we should be able to access everything. So just for the sake of completeness, I just want to show you our POJO right here. So we do have our recipe, which contains the title, ready in minutes, a summary, and certain instructions. And that's it. Great. So now let's go back to our application. And of course, in here we need to add the business logic now. And therefore we need to set, or we need to create our recipe or our HTTP client and call the Spunecular API. So what I'm going to do here is to create a new HTTP client called recipe client, and client, I need to pass some attributes to this client. Therefore, let's put our valuable parameters or very valuable attributes up here. So we need the URL and the API key. And now I can just put in the URL and the API key right here to create this new recipe client. And after having done so, we can now easily call, or we can easily request one recipe from our recipe client. Great. And of course, this returns a recipe. Whoop. Perfect. In order to send back some attributes to Camunda Cloud, we need to set these in our variables down here when completing the command. Okay, I just added this string or this response back to Camunda Cloud offline as well, because it's rather nasty with all those quotation marks. But now we should be ready to execute our code, and it should be theoretically working. But there's of course one thing we have missed so far, and this is set within the, or should be set within the application properties. So we need to configure our connection to Camunda Cloud, and therefore, as said already previously, we need to create some kind of API client. Therefore, we do select our cluster, we go to API, and right here we can create client credentials. And for our purposes here, we can call this dev client, which connects to ZB. Creating this leads to various credentials. So we need to have the cluster URL, the client ID, and the client secret. Perfect. Now we just need to add all this information to our application properties. Okay, just copied our cluster URL, the client ID, and the client secret to our application properties. But of course, we need to assign them to actual properties which do exist. Therefore, we can rely on, for instance, the on these kind of properties which are already given. So for our interest is, for instance, this cluster ID, and we can set the cluster ID to this part of the cluster URL. So let's do so. Also of our interest might be the client secret. Let's see whether we can find it. So it's right here, and there we can just copy and paste this little key, and afterwards we do still need the client ID. So let's add this as well. Client ID, here we go. And very interesting as well is that we should add some ZB client region, which is BRU -2. And last but not least, we should give our worker a name. And this is the default name, and we can now call it, for instance, dev client. Something like this. Perfect. Now we can just delete this part right here. Great. So without any further ado, let's try this out. So we can start up our application in here right now. Let's do so. And it seems to be running. And now we can switch to Camunda Cloud once again. And for now we do want to start our process. So we can just open up our diagram and say, let's execute it to or on our development cluster. Great. As a next step, we can open up our cluster right in here and access various tools. For instance, operate, we might want to launch it, we want to launch task list, and we want to launch optimize. To start with, operate might be very interesting, and you can see there's already one active instance. So maybe let's check it out right away. In here we need to select a process, find and cook meal, and there we can see we do have one running process instance, which is currently waiting for the worker to pick it up, to choose the recipe, and from our cooking website. So maybe let's just see what our Java application is doing at the moment. And apparently it hasn't picked up anything yet, which shouldn't be the case. So let's figure out what happened here. So there are multiple possibilities, and I guess the one which I missed is to actually add some proper worker name here, because going back to our diagram, you can see that the type of the worker was called recipe worker. So we need to use this type and link it up in here as well. So now we have added the recipe worker. We start up our Spring Boot application once again, and hopefully we get a job. Activated 1 jobs for worker, dev client, and job type recipe worker. Okay, so something has happened in here, which is great. Switching back to our operate monitor, we should see now that our process is moving forward. Yeah, exactly. So right here, the instance we have previously created went down the path to decide on recipe. And that's where task list gets interesting. So we can switch to here and we see there's a new task which was created, and it's called decide on recipe. So I can claim it in order to start working on it, and there you can see the title. So for lunch I will get some cinnamon twists today, which is kind of great. So yeah, I certainly do want to cook this, and afterwards I can complete this task, and we should be able to see the process moving forward in operate as well. So refreshing here, let's see, yes, we went down this path, and now we should be able to take a look on task list again and see that we have, or we can cook our meals. So down here there is our summary or the instructions of the recipe, and of course it's in HTML, so maybe we should have filtered out all these HTML elements, but in general you can see what needs to be done. The representation isn't that nice, but for our testing purposes that's definitively enough. So once again, I can claim it, I can complete the task, and then we can go back to operate and see that hopefully soon the process has finished. Yeah, it did. So that's wonderful. Another thing we can just try out and take a look at is Camunda Optimize. And Optimize is used in order to simply analyze the processes and the process instances which have flown through the system. To get started with, maybe let me create a new collection. We call it recipe collection, or recipe process collection. And in here we can link up data sources. And for our interest, of course, we go with the find and cook meal process. Selecting this, adding this to our data sources makes it now possible to create dashboards or reports for this process. So to keep it easy and simple in here, let's just create a pre-defined dashboard, so process performance overview for our find and cook meal for the version 2 of the process. So we can create this, and then you can see what has happened so far. And there are already 2 completed process instances, so I tried it out before I recorded everything for you. And you can see which tasks took longest on average. And that's pretty interesting to see, because you might remember we need to wait here in order to fix our worker to process this task, and then our user task went quite smoothly. Cool. So these are the Camunda Cloud things I wanted to show you for today's session. I've also edited the GitHub repository to our little Java worker in the video description below. So hopefully this is useful to you as well. And let me know whether there are other cloud related topics which are of interest for you. Great.